All right, let's get right into it. We are tackling one of the trickiest parts of the ACT's science section. You know the ones, the best experiment questions. But here's the thing. The secret isn't about being a science genius. It's about seeing these questions for what they really are, a logic puzzle.
Have you ever find yourself just staring at a page with four different experiments and your brain just kind of starts to short circuit? Yeah, I've been there. They all look so similar and you can feel the clock ticking. It's such a classic spot to get bogged down and lose precious points.
Well, here's the good news. You are definitely not alone in feeling that way. And even better, there is a super simple, almost foolproof way to get these right. Every single time. It all comes down to one simple, powerful rule that just cuts right through all that confusion.
And that secret is what I like to call the one variable golden rule. Seriously, this is the key that unlocks pretty much every single one of these best experiment questions. Once you get this down, everything else just clicks into place.
Okay, first, let's meet the key players. You've got the independent variable. This is the star of the show, you know? It's the one and only one thing the scientist is actually trying to test. It's the cause in a cause and effect relationship. So if the question is, does sunlight make plants grow taller? Sunlight is your independent variable. That's what you're changing.
So what's the result? Well, that's the dependent variable. This is the effect. It's what you measure to see if your change actually did anything. In our plant example, the growth of the plant, how many inches it grew, that's the dependent variable. Its outcome depends on the independent variable. Makes sense, right?
And now for the most important part, the real secret sauce for our golden rule, the controlled variables. This is, well, it's everything else. The amount of water, the type of soil, the kind of pot, all of it has to be kept exactly, and I mean exactly, the same for all the plants in the experiment. And why is this so critical? Well, think about it. If you change the amount of sunlight and the type of soil, you have no idea which one actually caused the change in growth. Your results are totally useless.
So it all boils down to this one simple idea. The best experiments are clean experiments. They're designed to isolate just one cause for one effect. On the ACT, your entire job is just to find the answer choice that does exactly that. Okay, enough with the theory. Theory is great, but let's see how this golden rule works in the real world with an actual example. This is where it gets fun. So here's our research question. Nice and simple. Does temperature affect plant growth? The very first thing we do is identify our independent variable. What's the one and only thing we want to test here? Temperature. That's it. Which means every single other thing has to be locked down and kept the same. All right, so here's a chart that looks a lot like what you'd see on the test. We've got 4 different experiments, A, B, C, and D, with different conditions. Don't let the numbers scare you. We have one mission here. Find the setup that best tests our question about temperature. So let's put on our detective hats. We are hunting for the experiment, or set of experiments, where only the temperature column has different numbers. The columns for light and soil type, they need to be identical all the way down. Let the process of elimination begin. Okay, let's start with the most obvious bad guy here. Just look down at experiment D. Temperature is different? Check. But wait, the light is different and the soil type is different. Whoa, that is a terrible experiment. It's changing 3 things at once. We can't learn anything from that, so it is immediately out. Gone. See ya. Okay, now let's zoom in on experiments A, B, and C. Look at the light column. It says 10, 10, and 10. Perfect. Now look at the soil type column. Same, same, and same. Now that is what we're looking for. The light and soil are our controlled variables. It's beautiful. Because the light and soil were kept constant across A, B, and C, this setup perfectly isolates our independent variable, temperature. See how it goes from 10 to 20 to 30 degrees? This means that any difference we see in the plant growth is because of the temperature, and absolutely nothing else. That right there is our winning design. So this is great, but how do you remember all this when you're under pressure on test day, right? Let's boil this whole thing down into a simple toolkit you can take with you. I want you to think of it like this, almost like a simple math equation. The best experiment equals changing just one thing, plus keeping everything else the same, which gives you clear, measurable data. That's it. That's the formula for a perfect experiment every single time. Now, you gotta be aware, the people who make these tests, they love to set traps. The biggest one, like we just saw, is an experiment that messes with more than one variable. Also, watch out for answer choices that forget a control group, or, and this is a sneaky one, ones that just throw a ton of extra, confusing data at you to make it look more scientific. Remember, on the SAT, best means most controlled, not most complicated.
Okay, you've got the theory, you've got the formula, now it's your turn. Let's put this new knowledge to the test and see how you do with a quick practice question. You ready?
All right, here's the setup. The goal is to see how salt affects the freezing point of water. So first things first, what's our independent variable? What's the one thing we should be changing? The amount of salt, right? Everything else needs to stay the same.
Okay, let's look at our options. Experiment A only changes the amount of salt added to the water. Promising. Experiment B, whoa, it changes the salt and the amount of water. Red flag. And experiment C uses different types of water, like tap versus distilled. So which one is following our golden rule? And the answer is, of course, it's A. It's the only design that correctly isolates our independent variable. B is a total mess because it changes two things at once. And C is no good because it introduces a new variable with the different water types. See how easy that is? Once you know the rule, the right answer just jumps off the page.
So please, let this be your mantra for the ACT science section. If you ever feel stuck, just take a deep breath and ask yourself, which one of these answer choices does the best job of testing just one thing at a time? Find the one that isolates one cause for one effect. So, there you have it. You've cracked the code. These aren't terrifying science questions after all. They're just logic puzzles in disguise. And it really makes you wonder, doesn't it? How many other parts of the ACT, or any test for that matter, aren't about memorizing a million facts, but are just about finding the simple logic puzzle hiding right there in front of you?